Welcome to Math 1324. This is section 4.4. We're looking at doing some basic matrix operations. So, in question 1 here, they want us to see if we can find B minus A. Well, the first thing is whenever you're doing adding or subtracting of two matrices, they have to be the same size. So let's see, matrix A here has 2 rows and it has 2 columns. B has 2 rows, 2 columns. So they are exactly the same size, so yes, we can do the operation. And to do B minus A, we simply subtract place by place. So let's see, minus 4, minus 4, I get a minus 8. 6 minus 2, I get 4. 9 minus 1 is 8. Minus 1 minus 5 is minus 6. So yes, it is possible to perform it, and we did it. All right, what about question 2 here? Again, we have two matrices. They want us to add them together. First off, is it possible? Well, yes, it is possible, because they are the same size. And so again, place by place. 2 add a minus 8 is a minus 6. 8 minus 8 plus 8 is 0. 5 plus 5 is 10, and 0 plus a negative 4 is negative 4. All right, so let's see. In question 3, they want us to figure out how do we do, if possible, the product of two matrices. All right, well, let's take this slowly and carefully. Matrix, the very first one here, is 2 by 2, 2 rows, 2 columns. Second one has 2 rows and 1 column. To be able to check if our operation is possible, I look to see, does the number of columns of the first matrix match the number of rows of the second one? Yes, they both have 2. So therefore, the matrix multiplication is possible, and the size of my answer will be the outside numbers, so 2 by 1. Now, how do we get the numbers? To get this first number here, this is in the first row, first column. I take row 1 of A and I multiply that by column 1 of B, the second one. Now when I say multiply, I mean term by term as I do this. So across and down, and then I'm adding them up. So you see I've got a 7 and a 9. See, here's the 7, here's the 9. That's from the first row times this column, which is minus 8 and 4. And so that gives me a minus 56. It gives me a 36. I add this together and I end up with a minus 20. And that's how we get this particular position. Now what about this one? This one is in the second row, first column. So I take the second row, first column. All right, so that gives me minus 6 times a minus 20, a minus 6 times a minus 8, sorry. And so we get a 48. I get a 7 times 4 is 28. Add them up and I get a 76. Now in this example, what I'm showing you here is this particular operation is not possible because this is 2 by 2 and this is 3 by 1, and the number of columns don't match here the number of rows of the second matrix. In this case, if I had a 2 by 3 multiplied by a 3 by 1, so this is a different example, example 2, example 1. In this case, it would be possible, and my answer is going to be 2 by 1. All right, what about question 4 here? Looking at question 4, we have two matrices. Sizes are 2 by 2 and 2 by 2. Inside numbers match, and so my answer is the outside numbers. Okay, outside numbers. And so the answer is going to be 2 by 2. And so it's going to look like this. Now, how do we get the answers? Well, let's see. The answer, A11, involves row 1 of the first one times column 1 of the second one. A12, first row times the second column. Second row, first column. Second row, second column. So let's see. So, to get this very first position, I would have 5 times 2 is 10 plus 0. All right, that's going to give me the 10. To get this position, where is that again? That's 1, 2. So first row times the second column. 5 times 4 is 20 plus 0. And I get 20. What about A21? Second row multiplied by the first column. All right, so second row, first column. 0 times 2 is 0, plus 5 times 6 is 30. To get this last position, second row, second column. Second row, second column. 0 times 4 is 0. 5 times 8 is 40. All right, so yes, it is possible. Now, what about this one? Let's see, this is 1 row, 2 columns, 2 rows, and 1 column. So the answer is the outside numbers, which is 1 by 1. So it's simply this first row times this column. 8 times minus 2 is a minus 16. Minus 3 times minus 1 is a positive 3. Add them up and we get a minus 13. All right, in question 6, we want to know, is it possible to take A times B? Well, let's see. This is 2 rows, 3 columns. This is 2 rows, 2 columns. So this number, the number of columns of the first, does not match the number of rows of the second. Therefore, it's not possible. How would I do in question 7, B squared? Well, let's see. That's going to be B times B. Is it possible? 2 by 2, 2 by 2. Inside numbers match. And so the answer will be 2 by 2. So remember, how did we get the positions? This position is going to be B1, 1. This position is B1, 2. This position is B2, 2. And this position is B2, 1. And that tells you what to multiply together. So first row times the first column. minus 2 times minus 2 is 4, plus 4 times 3 is 12. B12, first row, second column. Minus 2 times 4 is minus 8, plus 4 times 1 is 4. 21, B21, second row, first column. 3 times minus 2 is minus 6. 1 times 3 is 3. And finally, B22, second row, second column. 3 times 4 is 12. 1 times 1 is 1. And then you simply add them up to get your answer. So again, remember, it's the rows of the first times the columns of the second. All right. In question 8, I want to figure out how to find A, B, C, and D so that this product is going to give me this solution. Well, we simply trace out how do we get there. How did we get to minus 2 and a minus 1? Well, let's see. Remember that this answer is C11. This one is C12. So how do I get the minus 2? First row, first column. So 1 times A is A, minus 1 times C, and it has to be minus 2. How do I get C12? Well, let's see. First row, second column. 1 times B minus 1 times D, and that's got to give me minus 1. See, so here it is. B minus D is minus 1. All right. What about this position? This position is C21, and this is C22. So 2-1, second row, first column. 3A minus 2C is minus 4. And C22, 3B minus 2D has got to be minus 1. So I essentially have two problems to solve, two equations each, where the unknowns are A, B, C, and D. So in the first one, let's see, I'm going to get rid of the C. So multiply through by A2. All right, so I got 3A minus 2C. All right, and so we continue. Let's see, I'm multiplying through by a negative 2 all the way across. So a minus 2a minus makes this a plus. Minus a minus makes that a plus. Add them up. All right, I get here 3a minus 2a is a. 4 minus 4 is 0. So if a is 0, so if here's a is 0, that gives me minus c is minus 2. Therefore, c is 2. In the second one, let's see, what are we going to get rid of? I'd like to get rid of the d. So I'm going to multiply through by a minus 2 again, minus 2b plus 2d, positive 2. Add these up. The d's go away. 3 minus 2 is 1. 2 minus 1 is 1. And so b is 1. Well, if b is 1, that gives me 1 minus d is minus 1. Or minus d is minus 2. Which gives me that d is 2. All right. So that gives us A, B, C, and D. So remember, with multiplication, first check that the size works out so that the operation is possible. And then it's the rows of the first times the columns of the second.